Okay, welcome back, and now we're going to start talking about another rule called the chain rule. Now, the chain rule is used for taking the derivative when you're dealing with the composite of functions. So now, before we start with that, it's good to know that we could use the rules that we've learned up to this point to find the derivative of a composite function, but it's cumbersome. So we have the chain rule. So the chain rule says that we can find the derivative of a composite function by taking the derivative of the outside function at the inside function multiplied by the derivative of the inside function. So let me do an example and walk you through what I'm talking about. Okay, so let's see what we can do with this one. This is just to kind of help derive this chain rule. So let's say we have h of t is equal to sine of x cubed. So this would be a composite of functions, right? So the sine function could be f of x. So sine x, and then g of x would equal x cubed. And so we would have f of g of x. Okay, so now let's apply what we know about taking the derivative. Okay, and then we'll see how this derives. So I'm going to just use the limit definition. So we'll say h prime of t equals sine, and we're going to do this at, not t, x. Let's do this at a. Let's do this at a point A. So we're going to use the definition that the limit, almost dropped my limit, the limit as x approaches a of sine x cubed minus sine of a cubed over x minus a. Okay. So now what we're going to do is, this doesn't really look like much, and it doesn't look like it'd be very helpful with this. Okay, so we're going to modify by multiplying the top of the bottom by x cubed minus a cubed. Okay, and then we're going to manipulate this. Or excuse me, rearrange things, and let's make it this way. So we'll say sine x cubed minus sine of a cubed, and I'm going to flip these. So I'm going to say this is x cubed minus a cubed, and I'm going to write this as x cubed minus a cubed over x minus a. Now, if we look at this factor here, we can see that this is in the form of a difference quotient. And so let's split this up into the product of two limits, right? We can do that. These are all continuous. So limit as x approaches a of sine of x cubed minus sine of a cubed over x cubed minus a cubed times the limit as x approaches a of x cubed minus a cubed over x minus a. Now, we can see that this part here is a derivative. It's the derivative of this function x squared, or excuse me, x cubed, okay? It has the right form. It's at a, right? So this is as a, it's x cubed, so this is f of x minus f of a over x minus a. And you're taking the limit as x approaches a, so this is the limit of a difference quotient. So this actually turns out to be the derivative of x cubed. So we'll call this, g prime of x. But we also know what that is by using the power rule, right? So this is going to be 3x squared, right? So we know what that derivative is, okay? And the thing is we know the derivative of this thing is at a, so this would actually be 3 times a squared. Okay, now, let's deal with this one because it's not so obvious that this is also a derivative. Okay, but let's do a u substitution. Okay, let's let u equal x cubed. And let's also recognize that as x approaches a, or excuse me, no, as u approaches a, what happens? Don't hold on a second. No. X. I want x approaches a. Sorry about that. So as x approaches a, because I'm looking at this here, so I want, as x approaches a, what happens to u? U is approaching a cubed, right? So now let's make these substitutions into the limit and see what it gives us. Okay, so now, here. So now, let me erase this. Okay, so now what do we get? We get equals, so h prime of x equals the limit as now u. Now, let me rewrite that. U approaches a cubed now, right? What happens to the limit? This limit here, I'm just going to focus on, we already know what this limit is, but let's focus on this limit. So this limit is going to be the sine of u minus sine of a cubed, right? And this becomes u minus a cubed. Now realize a cubed is just a constant, right? The key is these two are the same. These two are the same, right? So now this meets, it's more clear with the u substitution that this meets a definition of a derivative, and it's the derivative of sine u. Okay? At where? At a cubed. Okay? So just think about that for a moment. So now, what do we get? We get, this is the derivative with respect to u of sine u at u equal to a cubed, right? So that's the that's the setup. So we know it's a derivative, but it's with respect to u. Right? With respect to u equal to a3, or at u equals to a3. Okay? Now, here's the thing. What is the derivative of sine u with respect to u? Well, that's going to be equal to cosine u. Right? And what's u? U is x cubed. But at a, it becomes a cubed. So cosine of a cubed. And so now, we put the product together. And so, what does it give us? Let me erase this. So at the end, again, continue with your notes. So what do we end up with at the end? We end up with cosine a cubed times what? 3 a squared. So we have the derivative of the outside function at the inside function, which is a cubed. Right? So at a, again, this is at a. And then we have the derivative of the inside function at a, which gives us this one. We're done. And that's the chain rule. So what we're going to do is, in the next video, I'm going to introduce to you the chain rule, so it'll be another theorem, and then we'll add some problem-solving strategies, and we'll jump in and we'll start doing some examples. Have a great day.